Good morning, T24 math students. Congratulations on making it through the first part of T24 math this school year. In this next section of the year, you will still be completing the workbook pages in the yellow workbook. However, you will no longer have to compete at the end of class. Your lessons will be delivered via video as they are now. You should bear in mind that you need to be as attentive to these video lessons as you were in your previous class period, because the material you are learning is designed to make you more successful on the STAR test at the end of this year. And if you do not pass that STAR test, you must retake the course, as you know. All right, bearing that in mind, let us begin. Please turn in your workbooks to page 5. We are going back to a topic that you have learned for several years. You started learning it in basic ways in elementary school. You did a lot of work with it in middle school, and it is something that we have done in math class. It is working with fractions. You do not have calculators in your new class period, which is good. We will not be using calculators this period. A lot of the math that you have learned in your algebra class, solving equations and systems of equations, and integer work, deals with whole numbers. The STAR test can substitute fractions in on any of these problems, so we need to be proficient at working with fractions. So this lesson is designed to get us proficient. All right. In example 1, we are told to simplify. That means reduce if we can. This first fraction can be reduced. The way you think about it is you're trying to find a greatest common factor. Looks like my page jumped over. Greatest common factor. So what number can both 3 and 6 be divided by? The answer is 3. When we reduce, 3 divided by 3 is 1, 6 divided by 3 is 2, so the fraction 1/2 is the reduced form, simplified. All right, the next problem, 2/8. Can you identify what the greatest common factor is between 2 and 8? If you guess 2, you are correct. 2 divided by 2 is 1. 8 divided by 2 is 4. The simplified, reduced version of 2/8 is 1/4. All right, so that's simplifying. It's a basic thing. Now we're going to talk about combining fractions when we are adding. In middle school, you remember, you can only add the fractions when they have a common denominator. So on A, we're in good shape. We simply leave the denominator as it is, a 9, and we add the numerator. 6 plus 2 is 8. In middle school, no doubt, you learned how to model that. So those of you who are confused as to why you would add the top but not add the bottom, the visual your teacher taught you was that you have a pie, you divide it into 9 sections. And this first one is you have 2 of those sections, 1, 2, and then we're going to add 6 more sections to it. 1, 2, 3, 4, 5, 6. So how many total sections? 8 out of 9. That's why the denominator doesn't change. It's still cut into 9 pieces, and we just have 8 of those 9 pieces. All right. You do not have to model this anymore. That's just trying to catch students up who do not remember how to imagine fractions. All right. B, we are trying to add these two, 1/4 and 1/5. The problem is the denominators are not common, so we can't add it. So the picture you'd have here, that's 1/4, and the picture for 1/5. Obviously, I'm not drawing those pieces to scale. That would take more time than I'm interested in spending on it. We can't add those because they don't have like pieces. So we have to first get them into common denominators. The simple way you do that is by multiplying by whatever the other denominator is. That will get them the same. So on this side, we'll multiply times 5. Whatever you do to the bottom, you also have to do to the top. So we're going to multiply the other one times 4. And we'll also have to multiply the numerator by 4. So the new problem would look like this. 5 over 20. That was 1 times 5 and 5 times 4. Plus 4 times 1 is 4. 4 times 5 is 20. So now we have a common denominator. We can add. We know it's going to stay the same. 5 plus 4 is 9. We much prefer it when they give us denominators that are in common. All right, example 3 is just like example 2, except we're subtracting, so you're imagining the same scenario. We need the denominators to be like each other. All right, we're in good shape on the first one, 9 and 9, so we simply subtract the numerator. 11 minus 5, we get 6. The denominator is 9. Hopefully, you are now thinking when you saw this fraction that this would not be our answer because it is not simplified. As we did on number 1, when a fraction can be reduced, we have to reduce it. What can both of these be divided by? The greatest common factor. If you said 3, you are correct. 6 divided by 3 is 2. 9 divided by 3 is 3. All right, I'm going to go ahead and pause my math real quick to emphasize something to you. If we have just gone through 1, 2, 3, 4, 5 problems, if you are currently sitting there and just copying what you're seeing on the board, that's a problem. You need to be thinking along. So every time I've asked, is there a common denominator? Or can this be reduced? Or what is the greatest common factor? You need to be thinking that in your head. You will not learn by copying. You will only learn by thinking. So I encourage you as we move on to this next one, as I ask questions, think it in your head. Don't just wait until we get to the answer. All right. B, can I subtract it the way it's written? And right now you should be thinking. And the answer is no, it has to have a common denominator like the previous one did. Since this does not have a common denominator, we can't the way it's written. So I'm looking back at the example we just did. What did we do when we had a different denominator? You should have just said we multiplied by the opposite denominator so that when we multiply, we end up with the same denominator. So what am I going to multiply this 2 by? That's correct. 3. Well, I shouldn't say that's correct. Maybe you didn't say 3 in your head. All right. When I multiply the denominator, I have to multiply the numerator by the same thing. Let's go ahead and write what our new fractions are. 1 times 3 is 3. 2 times 3 is 6. I apologize. I don't know why the notebook is jumping like this. 3/6 minus 1 times 2 is 2. 2 times 3 is 6. So we have 3/6 minus 2/6, and we're left with, there it goes again, jumping, 1/6. All right, let's move to example 4. Right now we are multiplying. When you multiply, it's a little bit easier than adding because we don't care what the denominator is. We just multiply straight across. That's 2 times 1, which is 2, 5 times 3, which is 15. Now, those of you that did not receive proper instruction in middle school and you don't remember how it was modeled, maybe you're wondering, well, why in the world did we have to have a common denominator when we're adding and subtracting, but now that we're multiplying, we don't have to have a common denominator? The model that shows why looks like this. If I have 2/5, that means I have a section, some portion of something, and I have it in 5 sections, 1, 2, 3, 4, 5, and 2 of those sections are shaded. Now, in my other direction, I have 1/3, so I have this in 3 sections, and only 1 of those is shaded. And the part that is double shaded right here is 2 out of a total of 15. So we're not needing a common denominator in order to add like pieces. We are cutting it in those fractions into more fractions. We're taking 2/5, which was this light blue, and we cut it into 1/3. I only wanted 1/3 of that 2/5. All right, let's move on to the next problem. B, when we are multiplying fractions, what do we need to do? All right, you should have just thought multiply straight across. 5 times 3, 15. 6 times 4, 24. Is this a proper way to leave my answer? You should have said no, because it can be reduced. So we're going to reduce. Can you please identify what the common factor is, the greatest common factor? Another way of asking that is, what can they both be divided by? You should have said 3. 15 divided by 3 is 5. 24 divided by 3 is 8. 5/8. All right, last two examples. I know this is long. We don't have this many examples on most lessons, but you are smart, educated high schoolers who have attention spans and can stay focused. All right, fractions are not much harder than multiplying. We're doing fractions. You're going to turn it into a multiplication problem, so it's going to be 1/6 times instead of divided by. But in order to do that, you have to turn it into the reciprocal, 4/5. You flip it. Perhaps your middle school teacher taught you something along these lines. K, F, C, keep the left, flip the sign, and change it over here. So it has to be moved. However you remember it, just do, when you divide a fraction, you multiply by the reciprocal. And now it's the same as it was. 1 times 4, 4. 6 times 5, 30. And we have our answer. I'm hoping that you are currently saying, no, that is not the answer. If anyone actually did that in class, whoever the teacher is, please email me so I can give them some sort of extra credit. They obviously can both be divided by a number. What number is that? By 2. So it is now 2/15. Okay. What are we going to do? We're supposed to divide these two fractions on B. Hopefully you said you were going to keep the left. We're going to flip the sign to turn it into multiplication. And we're going to change the way this one's written so it's 8/3. All right, 1/6 times 8/3. Multiply straight across, and we're left with 8/18. That can obviously be reduced. Divide by 2, divide by 2. We're left with 4, and there it goes jumping again. 4/9. All right, last example. Hallelujah. Now we're getting into what the problems that you would be seeing on the STAR test would somewhat look like, because we're in algebra, so now we're introducing variables. So, what do you have to do when you have a number in front of parentheses? Hopefully you just thought you're supposed to distribute the fraction. All right, so now we're going to use the information we just learned about how we multiply. It's supposed to be 5/2 times -2x, and also 5/2 times 11. As you can tell, we simply distributed the multiplication to both of them. Why did we multiply? Because when a number is in front of a parentheses and there's no symbol, it means multiplication. All right, the only new thing you need to learn about this is that when there's a whole number, the denominator is a hidden 1. So as we multiply straight across, you'll multiply the numerator times the 2, the -2, and you'll multiply the denominator 2 times this 1. All right. What is 5 times -2? -10. 2 times 1 is 2. So we could write -10/2. But hopefully someone in this room is remembering from middle school, before you cross-multiply, or multiply here rather, you can reduce it by saying, if this is in my denominator and this 2 is in my numerator, we can reduce it so it's just -5/1x, or just -5x. If you didn't see what I just did, then you could have multiplied 5 times 2, 2 times 1, and then reduced it to 5/1. All right, plus 5/2 times 11. You multiply numerator times numerator and denominator times denominator. 5 times 11 is 55. 2 times 1 is 2. At this point, can I add a regular number, 55 over 2, there's no variable with it, with a number that has a variable, x? Hopefully you have just said no, you cannot combine. They are not like terms, so we have our answer. All right, we have finally made it to the last problem. What do you have to do with this fraction which is in front of these parentheses? If you said distribute, you are correct. 4/3 times 7/4 x. And also, since it's a minus sign in between, we put a minus, just like last time it was plus, so we left a plus there. Minus 4/3 times 4/3. This is the 4/3. That's the second one. That's the first 4/3. And now we're going to multiply where we can multiply. Numerator times numerator, denominator times denominator. 4 times 7 is 28. 3 times 4 is 12, and the x is still there. 4 times 4 is 16. 3 times 3 is 9. Is that my final answer? Hopefully you said, no way, Jose. We can reduce it. So 28 over 12 can both be divided by, if you said 4, you are correct. How could we have stopped ourselves from having to reduce it now? By, instead of multiplying at this stage, seeing that in the numerator and the denominator there was a 4, that would have left us with 7 over 3x. That's what we were talking about up in this top section that some of you might not have seen, where we have a 2 in the denominator and the numerator. We cross it out and it leaves us an easier way to our answer. But as I said before, if you don't notice that, still multiply. Then when you reduce, you'll still get the same answer. All right, so we're now done with this part. So we have to get to this part, minus 16 over 9. Can that be reduced? No. All right, there's the final answer of all of the examples. This took a little longer than normal because there are more examples than normal. You are now going to be completing the rest of this sheet, starting on number 11 and working your way through. Please bear in mind 2 things. 1, some of you are going to start complaining, well, I didn't understand what this person was saying and I don't know how to do this. Well, 2 things. That doesn't get you out of doing the work. Second thing, you're still going to have to know how to do this for the STAR test. So if that's you and you still don't know how to do this after this video, go to your algebra teacher at lunch. We need to learn this material. You are not going to be complaining to your current teacher. You're going to work hard and dedicated. You're going to get the work done. You may check your answers with the teacher. Good luck and Godspeed.